Now find the magnitude of the frictional force and acceleration of the block. So first of all, make free body diagram of that block. mg, work on downward, so 5 into g. Okay, if g is 9.8 meter per second square, so 5 into 9.8, that is how much? That is 49 Newton in downward. Okay, normal force act on which direction? Here, because 100 Newton apply force here, though, and that wall is not moving in x direction. So N1 act on in which direction? Like that one. So N1 is equal to 100 Newton. Why? Because of net force in x direction is 0. Net force in x direction is 0. So N1 is equal to 100 Newton. Okay, now after that, here applied force 49 Newton. So frictional force act in opposite direction F. So this block is moving or not decided by frictional force. There are two frictional force here given, mu s and mu k. So mu s means static frictional force, ms, that is mu s into n1. Mu s is how much? 0.4 into n1 is how much? 100. So that is 40 Newton. Okay, and what about Fk? That is mu k into n1. That is how much? 0.3 into 100. That is how much? That is 30 Newton. Okay, after that, if you see very carefully, applied force 49. Okay, motion is possible if applied force is greater than Fs. Clear? If motion is possible only if applied force is greater than limiting friction. Okay, limiting friction is how much? 40 Newton. So 49 is greater than 40, so motion is possible, means A is not 0. So what about motion equation? F minus, during motion which frictional force act? Only kinetic. So F minus Fk, this is equal to mass into acceleration. So A is how much? F, this is equal to 49 minus Fk 30 divided by what about mass? 5. So that is 19 divided by 5, that is 3.8 meter per second square. Okay, acceleration is 3.8 meter per second square. And what about frictional force? Frictional force during motion, which frictional force act? That is kinetic friction, so 30 Newton. So final answer is D.